Right. I'm going to get started here. I think just as a reintroduction, the webinars that we were doing in 2019, 2020 were a little more product focused. They were things where we were trying to talk about Z band and the things that we were doing. This is obviously the first one for this year, and the schedule that we've set up for this year is a little more kind of informational. So right now you can go to a link on our website, and I believe you probably get it in the follow up from this webinar as well, where we already have 12 webinars plotted out for the year. We're calling them Webinar Wednesdays. It should be the last Wednesday in each month, and really what we're doing is just attempting to go through and do kind of a non-Z band general industry webinar, and then follow that up the next month with a product that's related to that, and then a more industry information webinar, and then follow that up the next month with some product specific stuff. So we're starting this year in this webinar with more of our bread and butter, which is RF monitoring and measurement. The other change in format for these is the anticipation here, or what we're trying to do is keep these webinars under half an hour. We're trying to make sure that we're conscious of everyone's time. We're trying to pull in bite size, usable bits of information rather than overwhelm you with an hour and a half of how to design a multicast network for IPTV, or how to, deal with an entire head end infrastructure in an RF system. So we're trying to keep this usable. We're trying to keep this bite sized information. My entire presentation today is about 8 slides. And we'll go into some detail on some of those, but for the most part, what we're going to do is just give you some information and an overview of what it is that we're doing. And obviously, if there's further training required, or if you want to go more in depth, then we can set you up some time with engineering or with your account manager. But today we're going to cover RF monitoring and measurement. As I said, this is kind of our bread and butter. This is what we do as Z-band. Um, and there's three basic components here for what we're looking at. We are going to be talking about where is the signal, which is a little bit harder to do now in the digital world than it was on the analog side of things, and how powerful is that channel, and what are the errors that we're seeing in that channel. Those are the three things that we're going to discuss. And really, those are the three things that we worry about when we're supporting RF systems and we're doing our troubleshooting. So, that first question, um, where is that channel? Well, the first question that we have to answer there is like, what actually is an RF channel? So when you're tuning your television, you go through, you do your channel scan, you get 2.1, 2.2, 2.3, 3.1, 3.2, 3.3. What you're seeing there is a representation of RF frequencies. Each of those RF frequencies are about, oh, not about, exactly 6 megahertz wide, and they're capable of carrying enough capacity for 38.8 megabits per second of data. With modern compression algorithms, that's enough data to put a 4K channel on an RF QAM stream. If I have any AV purists on the attendee list right now, I fall on your side with the whole 4K thing. Once we're actually compressing it down to 38.8 meg and then pulling it back apart on the receive end, it's not actually 4K anymore, because we've compressed well over a gig of data and reduced it almost 25 times to its original size to get it into this 38.8 megabit stream. But that being said, it is enough to put out what broadcaster would consider to be 4K content in terms of the resolution and motion vectors and that kind of stuff. So 38.8 meg is a lot of data. And this is a lot different than what it used to be when we were talking about analog video. And I still bring up analog when we're doing these presentations, because even though the analog sunset and digital revolution started 2007, 2008, right around the time the first iPhone came out, um, we still deal with analog customers on a regular basis. A lot of our client base is still dealing in analog video programming, analog modulators. We had engineers on site at a client last week who still all analog head end. Back in the analog days, or now, I guess, depending on whether or not you're that client, um, That's one channel, right? That 38.8 megabits of data, that 6 megahertz wide frequencies, that's one channel. That is channel 2, channel 3, channel 4. I may or may not look like it. I don't know anymore. But I was young enough to remember having to walk up to the TV and turn the knob when you were changing channels. And that's functionally what you were doing. You were tuning that television set to a different frequency. And if it didn't work right, you had to go out and walk around the back of the house and kick the satellite or kick the antenna to try and move it in the right direction. Um, where we're at now is you can fit multiple 1080 programs, one big 4K program, um, into that 6 megahertz wide carrier, which is how you get 2.1, 2.2, 2.3, 3.1, 3.2, et cetera, when you're doing program tuning. And the reason that that matters is because that's not always how that information gets represented when you're looking at it on a TV screen, right? Sometimes that what you see rather than 2.1, 2.2, 2.3 is a VCN, which is just this is channel 3, this is channel 4, this is channel 5. And that is a virtual channel number, which you can see on the screen here. And what that is the actual representation of the digital data that you're getting into a channel number. And it's really just for convenience, ease of use, comfort level with users, right? I travel quite a bit, and so you'll go into a hotel, the TV system, depending on how it's mapped or how it's set up, may still show you the 3.1, 3.2, 3.3. But a lot of folks have gone to this VCN platform where you're seeing the whole part, you're seeing the whole number. And in this image graphic, you can see on the right hand side of the screen here, at least it's on the right hand side of the screen for me. I hope it is for you. Um, you see the VCN column on the left, and then on the far right is the actual frequency that things are residing on. So if you look at these channels, you can see 2, 4, 5, 7, and 8 are all actually on, ooh, and 9 are all actually on the same frequency. But it's represented on the television as 2, 4, 5, 6, 7, 8, 9, even though they're all probably coming in at 35.1, 35.2, 35.3, or whatever the corresponding EIA channel is there for that frequency. Um, and the reason that that's important is the bottom bullet here. What this causes for us a lot of times, and what it'll cause for you and potentially for your clients, depending on exactly what your role is here in troubleshooting TV systems, is confusion, because the client's going to call and say channel 55 is pixelated, and you don't necessarily know what that means. Is it VCN 55? Is it RF frequency that corresponds to 55? And that link that I had on the previous page will give you a map of what those corresponding channels are with their frequencies. Um, and it's really difficult to troubleshoot because there are times where you're going through this process of troubleshooting a channel, trying to get RF measurements, which we'll cover next, from that channel, and you're looking for the wrong thing. Um, in 2020, Mark and I were traveling together in Florida. We were down in Miami at a hospital that has a Z-band installation, and we walk into the facility. Customer gives us the channel map, and we start pull the meter out, scrolling through the channels. There's nothing. There's no content on any of these channels that the client says they have. And really, what we had is a map of the VCNs and not actually a map of the incoming frequencies. So, as simple as it sounds, and it's kind of like a basic tenet of RF, one of the things that we have confusion with our clients, and one of the things that causes problems with our ability to troubleshoot remotely, is we're just not always speaking the same language as what the client is, because they're looking at a channel number that's displaying itself on the television, and behind the scenes it's just a completely different frequency. And to be really transparent about this, more and more with service providers and their ability to compress content, H.264, H.265, continually make things smaller, they're actually taking up less and less bandwidth in terms of RF frequencies, um, than what they had been to deliver you more programming. So there's a lot of channel lineups that we see that are stacked, kind of like you see here in this image on the right hand side, where you're fitting three, four, five programs onto one 6 megahertz RF channel, and you're actually being able to deliver 100 programs of content in 25 or 30 RF frequencies, which makes it a little bit easier from a troubleshooting standpoint, but far more confusing on the client side of things when they're looking at channel number 100 or channel 75, and it doesn't exist in the in in the in the RF meter when we're actually taking frequency readings. So this is a basic one, but this is always the one to start with, because if we can't decide where the channel is, we can't troubleshoot it. We can't figure out what's going on, and this doesn't even account for the potential of TVs that have issues with VCN mapping, and we've run into that a couple of times with kind of off-the-shelf stuff, or televisions that need a firmware update and aren't picking up VCN channels appropriately. Um, this this is a problem. I mean, it is something we run into on a regular basis, and it's really just kind of the first conversation we have when we're troubleshooting. Does the channel that you're telling me the TV is displaying actually match that frequency? Once we understand that we're actually troubleshooting the appropriate channel and we're looking at the right block of channel groups, the next thing to do is measure um, that RF content. And the image that you see on the right hand side of the screen there is a Televis H30 meter. These are the ones that our engineers have standardized on. I believe now we're working with some Televis H30 pluses, which have the ability to actually, do a TV screen so you can watch the content as well. Um, so we need to measure the power. And generally, Cable Labs, who's kind of the go-to for standards in cable television distribution, has recommended input levels to TVs at minus 15 dBmV to plus 15 dBmV. Um, we like to be a little more precise than that. If you have a Z-band system, what we're trying to do to tune you most of the time is hit 5 dB plus or minus 5 on either side. So really 0 to 10. There will be some instances in longer runs or extremely short runs where we vary from that a little bit, but really we're trying to keep you in that 0 to 10 range if you have a Z-band system. Um, the cool part about this is digital television is so much more forgiving with power levels than analog was. You would get a roll off pretty quickly with analog once your power levels started to get down there, just because of the way that the tuning worked. With these digital televisions, we can pick up content. You can get quality digital TV. We've been out in the field and seen minus 11, minus 12 coming into televisions, and picture looks great. Can't tell that there's anything going on. But that is really the range that you're looking for, is to try and be, like I said, Cable Labs minus 15 to plus 15, but really 0 to 10 is kind of where we like to be. And we'll read a lot of specifications, a lot of Division 27s, where they're calling out 0 to plus 15 or 5 to plus 15. People don't like to see negative numbers. It's weird. We didn't do well with negative numbers in school when we were doing math, so we just try and eliminate them as adults. So we try and keep those numbers in the positive side of things. Um, and you use your RF meter to measure that out, and hopefully we're where we need to be. And that power can vary from channel to channel, and it can vary. And this is kind of one of the important parts about this from a webinar standpoint, and maybe where we dive into farther training if you want to get a little bit more of it. It can definitely vary from floor to floor, from room to room on a given floor. And that's really going to be infrastructure dependent, right? So one of the things with the Z-band ZTV system uh, that we try to solve is you have that bail-in behind each television, and that bail-in behind each television is communicating back to the IDF, and it's doing amplification, attenuation, sloping, really depending on what it is that we're trying to do, how far away that it sees it is from the telecom closet. If you have more traditional infrastructure, though, if you've got a coax system, let's say, and you've got a trunk and tap platform rather than a home run platform. You're bringing that coax up the riser, you're tapping off. Maybe you've got some splitters in your infrastructure. Maybe there's an amplifier, and then somebody reaches up into the ceiling to give themselves television, and boom, now you've got a splitter that you don't know about. That's gonna change your power, right? Anytime you do a 1x2 split of a coax infrastructure or of an RF infrastructure, you're basically losing about 3.5 dB, unless you're, but with taps and some other things, these numbers can vary. But if it's just a passive splitter, you're going to lose about 3.5 dB every time you split that signal. And so when we're talking about a range of, 0 to 10, you can only really do a couple of splits until we're going to lose that power, right? We're not going to be able to be in the sweet spot for these digital television tuners. And what complicates it beyond that is if you're using category cabling, you're also losing power just on the length of the run. Rough numbers off the top of my head. If you're dealing with RG6, at mid-range frequencies, you're going to lose about 6 dB per 100 feet of cable. If with RG11, I think that number is closer to 3 or 4 dB. At the higher frequencies, the loss is a little bit greater. When you're dealing with the Z-band system, you're working on category cable. That loss is almost exponential. So at the lower frequencies, down in channels 2, 3, 4, 5, we're only losing a little bit, maybe 10, 15 dB, for an 80-meter run. But if you're doing up at, let's say, 700 megahertz or something at the high end of the frequency spectrum for cable television, over category cabling, you're losing 50, 60 dB, depending whether you're 5, 5E, 6, 6A. There's some variability there in the cable and how well the cable's manufactured. So the numbers are always a little bit round and not as precise as I would like them to be because I was a math major. So I like the numbers to be very precise, but that's just not how the real world works. So what you kind of end up with is this system where we've got an amplifier here, a splitter there, we've maybe got an attenuator over there. And these infrastructure failures are really where we see a lot of these system performance issues, where we see problems with distributing cable television is because we've got an amp that nobody knows about, or we've got a couple of taps that were put in to service some additional TVs, and everybody forgot about that because this isn't really a documented system. So making sure that we're taking these measurements and understanding what our power levels are is really one of the more interesting parts of supporting these RF systems. And as some of you on the line know, I know I'm preaching to the choir to some of you here. The terrible part about all of this is if you make change at location X, you're affecting everything down the line, right? So if we add an amplifier because I need to get a little more power to the CEO's office, well, if I add that amplifier to get more power to the CEO's office, am I then overdriving some of the TVs that are earlier in that chain? Or if the CEO's office is midway down the hall and I add that amplifier, did I add enough power to get all the way out to the edge where the administrative personnel are sitting? Right. These are the kind of things that we're dealing with all the time. And really, this is one of the beauties of the Z-band ZTV system, and one of the reasons that we have success with positioning that with clients on an annual basis is then the Z-band system is doing all of those calculations for you and giving you a more reliable platform for the video distribution because it's this one-to-one relationship with the port on the ZHC out to the bailent versus that coax infrastructure where you're really doing calculations on a drop by drop basis. We're working on a TV system for a VA hospital right now. We're still in the middle of the drop by drop calculations. Um, and so, yeah, the power levels, even though it seems pretty straightforward, these can vary from channel to channel. These can vary from television to television. These can vary from floor to floor. There's a lot of dependency here on the quality of your infrastructure and the design on your infrastructure to get those power levels correct. Um, the other thing that we have here, once we've established that we're looking at the right channel, we have established that the power levels are good. We're in that sweet spot. We're looking at positive numbers because people don't like negative numbers. It scares them, makes them think of their bank account. Not good. Is we want to measure the actual quality of that signal. And this one is the one that's finicky, the most finicky for digital TV systems. Because with analog, and I've got it here on the PowerPoint slide as well. Like I remember waking up to turn on the television, and if it wasn't broadcasting or you were on a channel that wasn't coming in really well, you got what I basically used to call the fuzz fight when I was a kid growing up, where it's just snow, distortion, noise, static, or one channel would bleed over into the other in an analog system. I mean, that kind of stuff doesn't happen anymore with digital, right? You don't get a digital bleed over channel into the next channel, or at least you shouldn't. Um, and you don't get static fuzz. You don't get this kind of slowly deteriorating picture that just gets a little worse the farther you get from the source. And then by the end, it's terrible. You get three basic phases of digital video. The three basic phases are digital video of it looks great, it's pixelating, it's gone, right? And normally, what's behind the scenes there of how we go from it looks great to it's gone in a matter of a couple of drops or a couple of floors or whatever is the MER, the modulation error rate. And both the modulation error rate for digital and your analog carrier to noise ratio, these are exactly what C to N carrier to noise is. They're ratios for how many of the bits of data that I'm getting are giving me errors or are corrupted. So you want these numbers to be higher, right? If I have a low MER, it means I've got a lot of error per bit of information that I'm receiving. So I don't want a lot of that. I want a higher number, 40, 44, 43. Um, and really, with digital video, and again, if you have this Televis H30 meter, if you've got an H30 Plus, if you've got other RF meters, you want to make sure that they can read MER or they can read these carrier to noise ratios, because just the power measurements in and of themselves aren't going to be sufficient for you to know that you're actually getting quality video coming in. So these MER numbers, once they start to reach the mid 30s, is where you start to get finicky. And again, it's math guy. It's not precise. I can't sit here and say, well, if you hit 37, you might as well throw up your arms and walk away. That's not really how it works, right? It depends on the quality of the tuner that's in the television and whether or not it can do that. There are some other factors that help determine whether or not an MER in the mid 30s is recoverable or not recoverable. Once you start to get down into the 20s, then you kind of universally like, oh, this isn't good. We're in trouble. Um, and so with the Z-band encode 8, what we launch at is a MER value of 43. And you shouldn't lose in digital a lot of MER throughout your infrastructure. Where we see MER start to degrade is normally when we've got failing equipment, right? If you've got an amplifier that's just boosted way too hot and it's throwing a signal from 0 dB up to 60 dB and just injecting a lot of noise through the amp, that's going to crash your MER as the amplifier is burning out. If you've got a modulator that's on the fritz and the one day you've got great picture on channel 7 and the next day channel 7's pixelated and the next day back to channel 7 and it looks great again, you might have a modulator that's going out, and as it's broadcasting and as it's creating that RF, you're losing MER, or the MER is varying in and out. So MER issues tend to come from the service provider if you have them, or there's something failing within your infrastructure that is injecting noise into the system, and then that noise injection into the system is what's causing those MER values to crash and representing itself as pixelization, as you can see there on the screen, the pixel out eyeball. And this one is the hardest to pinpoint, right? And the problem with it is it's also, because it's the hardest to pinpoint, it's the hardest to correct. One of the three issues that we're talking about, if we have channel 7 and it's actually represented as VCN channel 10, I can eventually figure that out, right? Like we can brute force our way through it, and we can, or somebody's got the correct channel map, or we can log into whatever the head end device and figure that one out. RF power is easy enough, right? You can attenuate it, you can amplify it, we can add cable simulators to kind of slope it out and even things up, make it as nice as possible to go into the television. With MER, that's a lot harder, right? Because I can't just put a device in front of the television and have it fix all of the errors that are injected into the system as it's made its way through the infrastructure to the TV. So you have to troubleshoot that MER. We have to figure out where exactly we're getting these video quality issues. Are we picking up some interference somewhere along the line? Do I have a piece of equipment failing? Do I have an amplifier somewhere that's jacked up to 60 dB on the output and that's blowing in a bunch of noise to the system? And then when you have that, you're normally either adjusting or replacing whatever piece of equipment is the source of your problems to begin with. This one's not as simple as like tuning a value on an amplifier or throwing an attenuator in to fix things. I mean, maybe if you get lucky, it can be, but a lot of times if you have MER issues, we're looking at actual equipment replacement, which can be problematic and potentially expensive. And in the world that we live in now, it might take you 8 weeks to get that piece of equipment. Who knows, right? So I'm sure everybody on the calls had to deal with that over the course of the last couple of years. But really, those are the three things that we look at, right? Are we troubleshooting the right channels? What's the power level on those channels? What's the quality on those channels? Those are the three things that we're going to ask about every time, right? And one of the issues that we have as Z-band and really as cable TV companies, all of the folks that we work with, is having clients with the equipment to be able to give us this feedback. Um, because if you can't get this feedback, RF video is a lot different than data. I can't log into a switch and take a look at the traffic on a port. I can't log into my Wi-Fi router and see how many devices are connected to my cable TV system. That's coax system, that kind of stuff. I mean, I should have some idea, but most of that infrastructure is passive. It's not giving you the feedback that you're able to get from some data infrastructure. Um, so that becomes the issue that we have is if you're trying to troubleshoot with a client and they don't have a Televis H30 meter, they don't really have anything to be able to give you feedback, you're troubleshooting blind, and it can become very difficult to give the support that we want to be able to give as a manufacturer and the support that our clients expect. So we do recommend that our clients buy meters. And if you continue to watch this space, I think we have a webinar slated for June, July. I think it's right around InfoComm time, so either June or July, with a product that we are launching this year that should help with the first two, right? With checking the channel lineup and with the power side of things. We will be able to put a device in the head end and monitor both of those. We are, I think, in the future going to iterate that product to add the MER and signal quality as an option, but just to get it out the door and to start, getting it into the field for ourselves and for our customers, we're going to launch a product here in June or July that's going to be really helpful for the first two parts of this, and then eventually will be useful in part three as well. And then there's one other consideration. I didn't put it into the kind of overview, but I just kind of tossed it on at the end when I was creating this presentation. If everything else is good, right? We know that our power is good. We know that we're troubleshooting the right channels. We know we've got good video quality. The other thing that we see a lot of in the field is issues with encryption. And standard coming from the service providers, the big one that everybody uses is Proidium, right? You are talking about Proidium encryption, keeping that content secure from the time that it's created at the service provider all the way out through their infrastructure into your infrastructure out to the endpoints. And in healthcare, hospitality, anywhere you're getting these kind of commercial grade televisions, they'll have a Proidium chipset in them, which will allow them to decrypt that content and be able to watch it even with the Proidium encryption. That is not always as effective as what it should be. There are times that we run into devices that are on the wrong firmware, or there's like some setting that got missed out of the factory and they needed a firmware update in order to do Proidium decryption. And we run into a lot, especially more in the corporate space or in like K through 12, where we're not necessarily getting commercial grade televisions all the time, where the TVs just flat out don't have it, right? Like if you go to Walmart and you buy a Roku TV, a TCL, that doesn't have a Proidium chipset in it. The at least not the one that I have in my house and the ones that I was looking at the other day when I was here. So if you try and feed that a standard coax feed with Proidium encryption, nothing, right? Or maybe you'll get, like I have there on the bottom bullet, purple screen, pink screen, audio but not video. Encryption issues kind of represent itself a few different ways depending on what the television is itself. But we do see a lot of this, especially in this kind of the corporate space, the non-healthcare hospitality space, where you're not buying commercial grade televisions. You're just kind of buying a consumer grade TV. And the reason for this is those consumer grade TVs, a lot of the time, are assuming that you have a device before the television that's going to do the decryption for you, right? You have set-top box, Apple TV, Fire TV stick, whatever that is, and then that's the device that's actually handling the decryption and just giving you an HDMI feed to your consumer grade television. Um, when that doesn't exist, when you've got a consumer grade TV in a corporate environment and you're trying to take a feed directly from Comcast, DirecTV, Dish, that's when we run into these problems. So there is this kind of fourth consideration here that I tacked on at the end of the presentation, where if your power is good, if you know you're troubleshooting the right channels, if you know that your video quality is where it's supposed to be, and you still have nothing, then we might be looking at an encryption issue. And I always like to keep that in the back of my head when we're troubleshooting with clients. But those are the big things. And like I said, try and keep this bite size, half an hour monitoring and measurement. I don't see any questions at this point in time. So I'm going to pop up the question slide, sit here for a minute or two and see if anything rolls in. And if not, thank you guys very much. You probably will be contacted by a territory manager after the presentation, just asking if you had any follow-up questions, giving you a copy of this presentation. And as I said at the beginning, but want to reiterate because attendees have kind of fluctuated here as things have gone. If you want to take a deeper dive into this particular topic, our engineering team is available for that and would be happy to set something up with you. Hey, thanks, Temis. Appreciate it, man. Talk to you soon.